Once you develop any system by designing the database, okay, using the relational data model, okay, you design the system. Now, then system is running perfectly. You can able to do the transactions. Okay, somebody is inserting the data, somebody is updating the data, and somebody is loading the data. Okay, and everything is going on. Then what you need? What else you need? Let it go like that. Business is running perfectly. You can able to update, insert, and the data. Okay, somebody is maintaining the data, backup and restore. Everything is happening smoothly because the way you design, it's happening. Okay, it's going on. After 1 year, after 2 years, what happens? Why you want to do the analysis? Why you want to do the analysis? You want to take some decisions. Why you want to take the decisions? Who want to take the decisions?
Further enhancement or improvement.
Further enhancements and improvements. Any purpose for the enhancements, improvements, integrating the system with the new system, or by just close the system. Okay. Then as a business owner, as a business, anybody want to take some decisions on a system, then how can they make the decision? For example, okay, they want to add one more concept to that system. Then how can they take the decision? Just they can go ahead and do it. Or today morning they got some benefits in their trade market, okay, and they want to route those benefits into the current application or current system investments. Where exactly they are going to invest those money? Just put that money in the account. It's going to happen. How do they know that where exactly they need to utilize that amount? Where they can get more profit, more advantage, and how can they know? Who will do that? But they don't have the history. How can they know? The system is running smoothly. How do you have the history? Backup is also same system. No? Backup is a replica of the existing system only. Then how can you get the information from the backup? Query, then what kind of query you'll write? I'll ask the question, okay? Can you tell me what was the total amount you got in last year December? What query you will write? What was the profit margin I got in last year December? Can you compare the profit margin with this year December with last year December? Write the query. Write a query. Let us take a simple example. Okay, don't take it personally. Let us take a simple example. Okay, now everybody is coming to the office now. Now, while coming to the office, how you are going to organize your cupboard? Assume that if you are not really doing, okay, assume that. What is the purpose of organizing the cupboard? Easily you can take the things, shirt, trouser, and shoes. Easily you can get those, like whatever the way you can do it. Even in the hotel, even in your room, okay? I'm not telling. The way you can easily access, okay, if somebody is doing instead of you, what will happen? You will keep on searching. Wait. Is it true or not? Then you have to do by yourself because you want to do the transaction. Like that, every system, if we are asking the system to run the banking, every bank is running the same way? They are running their own way. Like we are organizing our own clothes for our own purpose, based on our own behavior, okay? Like that, every bank is doing the transaction based on their model. That's why they are asking their system to design according to the process they want to do. Okay? Means what? Every system is doing the different business. Then how can you take the decision on each system? Can you take one simple decision on each system? Information means what? You need to know about their environment, information, and how exactly they organize that information. That organization is called data modeling. No? How exactly they did the data modeling we need to know. Like for example, take this one. When you are organizing your clothes, okay, that you are organizing the based on your own way of just easily pulling the, okay, shirt, trouser, whatever it is, then wear and come to the office quickly. Okay, then that is running. After 1 week, when you want to go to laundry for washing, then what you'll do? Are you going to take the same way into the laundry room? What you will do? You need to take a decision. With shirt, you need to take to the laundry room. That's what your decision. Then what you will do? What you will do? You will blindly, whatever happens, take it and take it to the laundry room. What you will do? Don't tell your personal, just tell me generally. What you will do?
Physical condition.
Condition means what? How do you know about the condition?
About the values. Condition of the values.
Then you know how many times you wore the shirt. That's what not. And if you are not even touching one cloth or one shirt or trouser, are you going to take it to the laundry room? Might be some stain happened on that one. Might be. Then how do you know all these things? You need to know what happened with that cloth. Until you don't know, can you take any decision? Can you take any decisions on the cloth? It might look fresh. Then by just looking, you cannot take a decision. You need to know the past history of that cloth. Without knowing that, can you do that? And who is the better person to take the decisions on that one? The person who knows the past history of that cloth. Is it true or not? Then how you are going to take that into the laundry room? In the same way, the way you organized for wearing. Different domain means what?
Different configuration.
No, don't take technically, generally.
Just grab everything together.
Grab everything, put it in a one laundry bag and take into. Then you are not worrying about, okay? Then what you are doing, the purpose is that, then how I can quickly move into the laundry room and how I can quickly wash and get back. And again, taking back, again you are reorganizing for the next day. Is that one? Now here, what you are doing, why you cannot use the same one per organization for the both purposes? Same thing. Okay, for the decision making also, can I use the same system? Anybody can take decision on any system. No. Okay, I can go to your cloth cupboard. I can take these clothes for washing. Is it perfect analysis? Is it perfect decisions? But they're not perfect. Means what? That system, the cupboard is made for decision making? Only for taking the clothes easily, not for decision making. Decision making depends upon what? Once you know the past history of every cloth. Okay? That is not the cupboard is telling you take some decision. Like that here, whatever the database you designed is for, what is the purpose? To sell the products or to run the system smoothly. Then if somebody wants to take the decisions, for example, let somebody is taking the decision. Okay, let us take, we are running the store, product store, like Best Buy. Okay, we own the Best Buy. Okay, suddenly one day morning, we are organizing the every product and we are keeping the database. If somebody is asking, I need a TV, then you are searching, this is the price, these are the brands available in, then you are able to tell. Okay, for that purpose, you are organizing the database for the Best Buy, or you are organizing the store for it. Easily they can go and to the TV section, they can see the demo and they can purchase. And music systems, computers, tablets. You are separately organizing or not? Okay? No. That is what for the everyday selling. One day, morning boss came. Asked me, oh, can you tell me from the last 1 month how much profit I got? Who's going to tell? First question, who is going to tell that answer? Who is going to tell? The counter person is doing his work. Where is the accountant? Where is accountant is doing his work? Salesperson is helping the customer. Who is going to tell the answer? Store manager is managing the store. The purpose of hiring you, hiring that person is to manage the store. No, he's doing his work. Who's going to tell? That is first question. Okay, if somebody is the boss, no, whoever he might ask, the person whoever he see, oh, can you tell me this one? Then what is that person should do? He has to stop his current work or not? He has to stop his current work or not? Then he has to ask, because he's a boss, or else he will fire him. Okay, he has to stop his current work and tell him the report and go there. Okay, the reporting is done. Okay, maybe the current work is disturbed. Current process is disturbed. One thing. Next. Okay, then if he is asking the question one day 10 o'clock, other day is 11 o'clock, if the report is going to be same. Time is correct. 10 o'clock or 11 o'clock. When he should ask. Maybe 10:30 somebody bought 10 TVs together. Possibilities there are now. Then which time is perfect? 10 o'clock or 11 o'clock? Think generally, don't think any technically. I'm not teaching anything. Okay? Think generally. I want everybody to give the answer. Okay. Now, which timing is correct? Which one is that? 10 o'clock you might get the losses. 11 o'clock report you might get profit. Next day's report. Then you want the people to wait to take the decision for next day. Every day, next day. When they are going to, they want to take some decision. What is the purpose of asking? They want to make some decision, or they want to take some. If profit is there, they want to take some money out and put it somewhere, or if the loss is there, they want to put some more money into this. When they can take the decision. Second, okay, they don't know the time when to take the decision and when to conduct it. First thing is that they are stopping the existing work. Okay, think technically. If this database is designed for if somebody is asking the product and take the product for the regular transaction, then if you are writing a report or if you are transacting, means what? That information is available in any single table? No, it's going to available from the multiple tables. Then what you need to do? You need to write a query and to join the multiple tables. But if the database is idle at that time, it is doing their own work. Then what you are doing ultimately? You are increasing the load on the same system or not? Will that affect the current system or not? If somebody is waiting for a product, they will enter the bill order and it will take system is slowly run. Because one more person is doing the work. Possibility is there or not? Means what? You are increasing the load on the same system. First thing, you are disturbing the current system. Second thing, you don't know at what time you need to ask the person or take the decision or analysis. Third thing, okay, you are increasing the load on the system. Then, even though I'm good with all these three, are you going to get the answer quickly? Are you going to get the answer quickly? Then what happened? All these things happen, whatever the information available in the system, current system only. What about if I'm asking the question about, I want to compare with the previous year's results? Then where are the previous year's results? Why all this is happening? If somebody wants to take a decision, why all these things are happening? What exactly we need? Past history, but where is that? Does not disturb the current existing system. Means what? Then that necessary information will call current decision only. What about the future decisions?
Must we take the whole day?
When to take? When?
When?
Yeah. Who will take it? When to take it? Periodically. But what exactly we need to take? How do you know that what type of decisions they want to take? One time they might ask for one decision, the next time they might ask for next decision. How do you know which one to take? Everything. You need to generate a different systems. Still, For your information, you kept it. In what format we need to keep it? Just as it is?
Another format. No.
Another format means what? What is another format?
Another format, this, I speak technically.
Yeah, go ahead.
The original database is 2 dimensions.
Mhm.
So that we can take it in another dimension,
What is that dimension?
apply the flow dimension or multi-dimension.
What exactly called multi-dimension?
Multi-dimension.
2-dimension means rows and columns. What is the 3rd dimension? 4th dimension. What is the 5th dimension? What is the 6th dimension?
That's on the identification of the data.
That is also one, either row or column, no? Either row or column. Okay? It is a standard cost and total standard cost. One column is standard cost, other column total standard cost. Why do you need a 3rd dimension?
You have to very fast to my data.
But where exactly? 2 dimension, one is row, one is column. Where is the 3rd dimension? Physically, we need to put it in the system, no? One is row, one is column. Where is the 3rd dimension? Okay, let it wait. People will confuse, okay? Later, we'll come to that point. Now, but what exactly is happening is that, okay, now, whatever the information we have, and we organize the information for the current transaction only. While designing the system, we implemented every plan to run the system smoothly. And we did think about how to do the analysis and everything. Right now, we got a decision. If you want to take some analysis, that analysis is not going to be perfect. Okay? That maybe we might write some queries, complex queries, but that might not be the perfect. And the data, the information, whatever you have, okay? For example, the product price today you are keeping as $20 and tomorrow you might change it to $21. How do you know yesterday that it was the $20? Is there any way you can know that? The record, once the record is updated, okay, do you know what was the previous value before updated? Is there any way in the queries to write? But the information is keep on changing. The information is keep on changing. Now, then you cannot rely on that information. Okay, and you don't know when to take the decision. If you want to take any decision, you need to disturb the current system, and you need to increase the load on the current system. Okay, and for that purpose, that actual purpose of designing that system is not for making a decision, not doing the analysis, running the system smoothly. That is the reason that system you are calling it as OLTP system. What is that? Online Transactional Processing System. Means what? To run the transactions. Okay. Now we know it. That system is only for helping us to do the transactions or running the transactions or or you can call it as an operational system. Running the current operations. Okay. Now, that system is not helping us much to take some decisions. Then what we need to do? Then we need to have one separate system. Okay. One separate system. Okay. That is it should only concentrate on taking the decisions or to do the analysis. That system is called what? Online Analytical Processing System. OLAP system. Okay. Or you can call it as Decision Support System, DSS. We need one system which should support to take a decision. But why we need another system? What are the problems we'll face if we are taking the decisions on a current system? Let us think about it. Decision Support System or OLAP system. Okay. Now, like for example, if your boss wants to take a decision, for example, okay, he recruited everybody and everything. Okay. Then he is asking a business analyst to prepare a requirement. I need to do this analysis. Then what is? You cannot directly go and ask the developer. Then what is that? What exactly the required information? Even he don't know where to go, where to find. Then what happens? You will tell immediately business analyst. Then business analyst generate the requirement. Then what is the business analyst will do? The requirement go to the developer. Then developer develops a report, maybe whatever he is using or anything. Then again it will become under the testing purpose. Okay. Now the testing is done. Next is what? Then business analyst prepare a report and send it to the boss. How much time it will take? How much time it will take? Is it going to happen in 1 minute, 1 day, 1 week, 1 year? Does it need to wait until that time? Or does it need to involve these many people to take any decision? He's the owner of the business, no? Is he need to depend upon these many people? Think generally or think system-wise. Then how can he believe the person, whoever is giving the information is correct? Take the decisions. To take the decision. Actually, does it need to involve these many people to take any single decision? Might be a complicated decision or simple decision, whatever it may be. Does it need to involve these many people? Is it necessary to involve these many people? Okay. Now, next, that is general. Then it is taking too much time. Okay. And does it need to involve these many people? Then everybody knows what decision the boss is going to take. Yesterday we discussed reports. Like that, everybody knows what decision the boss is going to take, then they'll make it necessary. I'm telling generally, but in the real time, does it need to depend upon these many people? Okay, and think technically, what is happening? Same database, everybody is accessing. The current system is accessing the same database. Okay, the reporting person is developing the report on the same database, and the testing person is testing the same database. Is that true or not? Everybody is working on the same database. What will happen to this database? It will increase the load. Okay? Means what? Currently only these three people are working because to run the current transactions. Immediately boss asks that one. Business analyst runs for the system to design the requirement. Okay? And then the developer take the information from the system to write some queries and develop the reports. And the testing people test on the same system. What will happen? Or else you might tell, oh, we need to have the separate development environment. Then what you need to do? Then we need to create separate development environment and separate testing environment. Then once the development is done, the data has to come here. Then how much time it is going to take? How much time it is going to take? Prepare. This system might be 10 TB of size. Are you going to creating the 10 TB of some? You cannot create just in seconds. You cannot create a same environment in just in seconds. Okay? Then what is the solution? Actually, what exactly the people want, your boss want, or business owner want, or decision maker want? You want one single step system, not this lady. One system, okay, to give the solution quickly. To give the solution quickly. Okay, like, okay, let us take, I'll show you the simple, okay, example. I want a system, the business owner want to have the system like, if I want to know what are the profits and what are the benefits I got from the last year business or any business, I need a system, somebody has to tell me, open the system, okay, we are going to work on it, don't, and they should open the system. Okay, they should open the system. Then whenever the boss is asking, okay, can you tell me how much, okay, total amount I have in my business? Yes, this is the amount, sir. Okay, can you tell me which department is having, can you tell me that amount depending upon each and every department? Here is the sir. Can you tell me year-wise from the last 3 years how much money I got it? Here it is. Can you tell me semester-wise information? Can you tell me quarter-wise information? Can you give me semester-wise or date-wise information or month-wise information? Can you give me, okay, which department is chosen on that information? Yeah, wherever it is true, pick out those information and give it to him. Sir, all these departments are not doing good business. There are only 1 or 2 departments. Yes. Research and development is doing some good business. Remaining, they are not doing good. This kind of system is called decision support system. Actually, the people want this kind of a system where they can make the decision quickly. Do I need to write a query? Do I need to generate a requirement? Do I need to increase the load on the system? I'm just getting the information just like that. This is called a decision support system. Then are you going to build just like that system? Then we need to develop that kind of a system simultaneously along with the current transactional system. That system is not going to happen in one day. Then we need to do step by step. What are those steps? What are those steps? Now, first we need to create a repository of information. But what information we need? What kind of information we need? What kind of information we need? We need to have the, whatever the transactions happen, the history of those transactional information. Okay, then the repository of historical transactional integrated information. Integrated means what? Keep it together. Okay, the repository of historical transactional integrated information is called, what is that? Data warehouse. It's called what? Data warehouse. Means what? We need a data warehouse. In other words, you can call it as a OLAP system. Okay, we need a data warehouse. Why we need a data warehouse means what? What is exactly the data warehouse is? Database is what? It's a collection of information only. Okay, database means what? The place where you can repository of collection of information. But data warehouse is what? It is also a collection of information. But what kind of information? What kind of information? The historical transactional information, not general, just like that information. Historical transactional information, the repository of historical transactional information is called data warehouse. Okay. Now, then what? Which transaction information? Which transactional information? Oh, with what? That information about your OLTP system. Okay, information about your OLTP system. Okay, in general word, the data warehouse is nothing but, if anybody is writing a diary habit, just like your diary. Okay, if I got your diary, I can take the analysis on your diary is there or not. Okay, the whatever the transaction, maybe we are friends, but in my diary I'll write in my perspective. In your diary you will write in your perspective. Is it true or not? Okay, means what? My historical information will be there in my diary. Your historical information. Like that, for every system, we need to have one separate system, okay, that should have the historical information. Then now tell me, can anybody create a history? Can anybody create a history? What you need to do? Whatever so happen, you need to note it down. Whatever so happen, you need to note it down. You cannot create just like that. Can somebody change the history? Is it possible to change the history? Is it possible to delete the history? Then what kind of transactions happen on the history? No transactions. Then what is the job you need to do? Load it and read it. Load it and read it. Load it and read it. That's what you need to do. Okay? You cannot create it. Can you create it? Whatever so happen just like that? You cannot. You whatever so happen, you need to write it. Exactly. Okay? Don't ask me if somebody is writing lies. Okay? Then whatever these happened along with the system, along with the person, anything, you need to write it. Then what you're going to do? For example, you sold a product. Okay, then what you're going to do? But to sell a product, you are going to display all the properties of a product, or else in your diary. Okay, you went to a movie. Then what you're going to write? All the 1.5 hour movie information you are going to write. What you will write? I went for movie on so and so time, and the result, the movie was good or movie was boring. Only that. Means what? You write only summarized information. And actually the whatever so happened is, it's a full detail, but you are not storing it. Full detailed information, only summarized information. To know at what time you went for movie. Log file is also doesn't have that information. Log file, if somebody is happening, okay, something is happening with the system, but not about the transactions happening with the system. Okay, now that is called data warehouse. If you want to go with the definition, it is a use it for the decision support purpose. It is a repository of historical transaction information, or you can simply collect a logical collection of data. A logical collection of data. But why do we need? Why do we need? Okay. Then we need to take the, by comparison with the OLTP system, online transactional processing system. Okay. But why we need a separate system? Because whatever we want to do, taking some decision, doing some analysis, is not happening perfectly with the current system. That is the reason we need it. Then let us discuss on why exactly we need it. Why? Why do we need it? Yeah, maybe let it happen late, delay. Let it happen some late. Let us make the decision on the same system only. I don't want to create a separate system, man. I don't have a habit of writing a diary. Maybe people can tell. Then what exactly? We don't get the consolidated information in the current system because every system is scattered because we granularized it. Is it true or not? We kept it in a smaller entities. Then to get the consolidated information, it is going to be a little bit different. And when you are putting in separate tables, when you write a query on the joining all the tables, what will happen? It is going to take much time or not? Then we are not going to get the query performance. If you join the multiple tables, obviously it is going to take extra time. Is it true or not? Then we cannot apply some research or analytical functionality on the same system because only we can update the data, transactional functionality only we can apply. We cannot apply the analytical functionality on the same system because that will damage the existing system. Is that true or not? To run the existing system, those analytical functionality might not be useful. Not be useful. Okay, and next. How the people want to take a decision? Are they going to write a queries process? Just they want to see the reports in a visualization and reporting format. Visualization means what? Dashboards, attractive dashboards. Okay, analytical information. They want to take, okay, some red color is going on, top out, take the decision. Okay, those tools we cannot implement on the current system. Okay, then we need a OLAP tools for the reporting and for visualization purpose. Okay, reporting, we have the reporting, Excel sheets and everything. Visualization, we have the dashboards. Okay, then we need to have. Then, what exactly after, yes, we assume that one, we take the decision, okay, we realize that one, okay, we need a system. Then, what you're going to do with that system? You design that system. What you're going to do with that system? What are the possibilities you are going to get from the system? What you're going to do with that system? Retrieve the information. You can retrieve from the current system, no? Then you are going to generate the consolidated reports. That is not possible on the current system. Okay, that you can call them as analytical systems. Okay, then finding the correlations and relations, and you can perform the data mining. Okay, data mining, we are going to discuss on that briefly about it, not fully. Okay, now then see the examples of the credit risk for the company, banks, Okay, insurance companies for the frauds and medical research and doing the analysis. Okay, the purpose. Okay, now, exactly. Then we need to, now we decided, everybody got the idea that now we need a separate system that should be static and that should contain the historical information. That system we are calling it as a decision support system or data warehouse or OLAP system. Okay, online analytical processing system. Everybody is clear about that system? Now we need to think about how it should be different from the existing system. Now we need to design that system. No? Okay, now can we design just like that from the air? No, it should contain the transactional information of current system. That is the reason we should have the entire understanding of the current system. Then only you can design the data warehouse. Without having the current understanding on the existing system, it is very difficult. Okay, remember guys, it will be very boring session, but you need to understand. Once you have the concept of data warehouse perfectly, then you can do whatever you want. Okay, now let us discuss about how exactly it is different from the existing system. Okay, now while designing the existing system, what you are going to do? What is the concentration you are doing? What is the purpose of designing the existing system that you did? Okay, then that is the reason you designed it. Now we need to know what is the purpose of the data warehouse or OLTP system. Then you need to know what is the purpose of the OLTP system, what is the purpose of the OLTP system. Because when you went to action movie, what kind of analysis you can do? Can you do the analysis on comedy? Yeah. How can you do that? The movie is completely, then can you decide, oh, there is no comedy in this movie. The movie is action movie, man. Movie is action movie. Then what kind of analysis you need to do? On the action part. Then related to the action part. Then you are going to the action movie and you are saying there is no comedy. Go to comedy movie, man. Okay? Simple, no? That is what? Okay. Goal means what? You should know what is the system is about and what kind of analysis you are doing. Okay? You cannot do generalized analysis on any system. Okay? Generalized analysis on any system. And you are selling, okay, some non-profit organization going to that, okay, show me your profit. That is a related question. Going to the non-profit organization asking to show me your profit. Okay, that is what. You should know properly about what system you want to take, on what system you want to take a decisions on. Okay, on what system you want to take a decisions on. Then define the structure of the system and define the size of the system and then improve the performance, and then you need to use the technologies used to define that system or design that system. Okay, now we'll work on one by one. Okay, let me know guys if you're getting bored, get a coffee. Okay, session is going to be theoretical. I know that everybody's okay, get a coffee, but keep awake. Okay, now we'll work on one by one. Okay, now we got the idea that we need a one system. Okay, now the data warehouse. What exactly the definition was data warehouse? Okay, it is the logical collection of information about the data. It's not just collection of information. We are not collecting any new information. Okay, we are collecting the information which is happened with the existing data. Okay, that's why we are calling it as information about the data. What kind of information is called? Transactional information. Whatever transactions happen. Okay, then are you going to write a diary when if you never visited London? Are you going to write about London in your diary? The transaction never happened. Then there is no question of inserting the London information in the diary. Like that, the transactions only transactional information. But is that one transaction information, or are you going to consider if we are both are friends? Okay, when we are writing a diary, okay, to know about our friendship, do we need to read only one person's diary or two people's diary? Why we need to read two? Anyhow, you wrote about me, I wrote about you, no? Exactly. Then you need to know the purpose of decision and the way of analysis. Depending on the purpose of decision, way of analysis should be different. Then you need to define, you need to collect the historical information depending upon the decision and depending upon your analysis. Then one system, you can do analysis 100 different ways. Is it true or not? One system, you can do 100 different ways. Is it true or not? One movie, 100 people, they tell 100 different opinions on that movie. Is it true or not? Why? Why? Because 100 different people analyzing in 100 different ways. 100 different ways. That is the reason they are telling the decisions on the 100 different ways. Now, that is called, might be. Now tell me, is that OLTP system is about some, about 20 tables, then how much OLAP system is going to have? Only 20 tables information? And depending upon the analysis, if you keep on doing the analysis, then the information, the transactional historical information will keep on increasing on the OLAP. Then to keep everything together, it is going to be impossible. Means what? It is going to be huge. Then what you are going to do? We are separating the data warehouse into the subsets called data marts. Okay? We are separating the data warehouse. Means what? The subset of data warehouse is called what? Data mart. Okay? Means what? We are categorizing depending upon the analysis. Instead of putting everything together, okay? What we are doing? We are categorizing depending upon. Okay? That is called the subset of data warehouse is called what? Data mart. Okay? That is. But you can do. There is one more way we can do that. And I need only these reports, man. I don't want to increase the load on this system. Okay? Only for the only particular purpose, only reporting purpose only I need it. I don't want to do the analysis and everything. Okay, but reporting, running the queries on the existing system, it is taking little time, but I cannot wait. Okay, then I need a one static system. Okay, then that static system should be like you told. That static system should be loaded periodically. Okay, I don't want regular transactions to be happen. If I'm taking the report morning, that report should be there until the next day. Okay, means what? I don't want to touch the system where the transactions are running. Then I can create a replica of original system. Or else I don't want to take the reports on entire database. I want to take the reports on the only few tables. Then what I do? I'll take those few tables and create a separate database and move the data by using backup and restore or whatever it is. Okay, that system only concentrating on the reporting purpose, you can call this operational data store. It is not actually data warehouse. This is actually the part of your database or operational system. You can call it as operational data warehouse or operational data store, ODS, operational data store. And there are three different ways. Entire data warehouse for the analysis. If analysis is going bigger and bigger, you can create a subset, means a part of one analysis for the one data mart, other analysis for the other data mart, financial sales analysis, separate data marts. Means what? The historical information you categorize. You are categorizing the historical information. For example, school diary, college diary, or year-wise diary. You can do it, no? Okay, or personal diary or work diary. People will make, kids make it, no? School diary, personal diary. Okay, whatever happened in the school will be in the school diary. Whatever happened in the personal life, in the personal diary. Some of the information might match. Take it. Okay, like that you can do the data marts and you can develop the only for reporting purpose. I don't need to do any analysis, any decisions, but I don't want to disturb the current transactional system. That is the reason I am creating a replica of current system with the required information, putting in operational data store. Okay, operational data store ODS system. You might hear these words. Now, yes. Now let us discuss on what exactly we need to design, then how the new system should be. Okay. Now, current system is operational system, then we are going to design the analytical system. What is the main goal of your current system, operational system? What is the main goal? It should be active. It should be active for the current transaction. Then that we are calling it as a primarily it should be primitive. Okay? Primitive means what? It should be active. Means what? It should help for the current transactions. Okay? Now next. What is a data warehouse? means analytical system should be? What is the primary goal? What is the primary goal of your data warehouse or analytical system?
What do you mean operational?
That's what we are talking about. Okay. Operational system is that whatever the system code you currently design, your tables. Okay. Means what, to running the transaction, you did the relational data modeling. No? Okay. You did the relational data modeling to running the transactional smoothly. To running the transactions, that's what you are calling operations or operational. In the currently operational system or transactional system. You can use the word called transactional system. Okay. Or else you are calling it as OLTP system. Online transactional processing system. Okay. Now, that system is not helping you to take the analysis or to take the decision. That is the reason we decided to develop a system called OLAP system. Okay. Online analytical processing system. Now, we are in the process of designing that OLAP system. To design that system, we should know how it should be different from the original system. What is the primary goal? It should be up and active every time, primary primitive. Then the next thing is what? You should derive, means what kind of decisions you want to take. Okay? Then without knowing what kind of decision you want to take, don't start designing the data warehouse. That is it. Okay? You cannot start designing because you should know what kind of decisions or what kind of analysis you want to do. Okay? Now, next, the data inside the system should be current, accurate as of now. Okay? The data should be, the information should be current, accurate, and as of now. The current information should be perfect in the system. Then what about analytical system? Are you going to keep the current information? The historical over the period of time. If you want to do the analysis of last 5 years, how much information it should be? It should contain last 5 years. Okay? And the last 10 years, last 20 years, whatever it is, you should know historical over the period of time. And this system is constantly updating, no? Okay? You are keep on updating the system. But are you updating this system? No, you are not currently updating. Less frequently updating means what? Loading with the new data. Okay? Less frequently updating, loading with the new data. This system is minimal redundancy. What is the purpose of minimal redundancy? We reduce the redundancy by applying the normalization, no? By applying the normalization. Now, what you need to do? We need to manage the redundancy. Why we need to manage the redundancy? Because if we both are friends, to take the perfect decision, I need to go through your diary and I need to go through my diary too. Oh, why I need to go to 2 diaries for same information? To take the perfect decision. Then I need to do the same process repeatedly or not. Okay, then mean I need to have the redundancy. Okay, I need to have the redundancy. Now, here you are going to keep the highly detailed data, means what? All properties of entity.
You need to have the redundancy, but you should also minimize.
Yes, managing. You are managing it. That's why you are calling it managed redundancy. We cannot just repeating the information. Okay, wherever it's needed, yes, required. Okay, wherever it is, that's why called managed redundancy. Okay, you are not increasing it. You are managing the redundancy. You are deliberately decreasing the redundancy, minimal redundancy. You are reducing the redundancy in the normalization. Here, you are managing. Okay, now, here you need to have the summarized data because once you consider the entities, what you are going to do? You are going to have the all properties. For example, to sell a product, is there any problem?
No.
Okay. Okay. Now, you need to have, once you have the product in your store, you need to have the complete list of details of the product, no? 100 or hundreds of specifications about the product. Okay. Now, once the product is sold, are you going to store all those specifications in your system, in your diary or in your information? What you are going to store? What is the product name? Sold it to whom? What was the price? What is the original price? What is the sold price? What date? What more information you are going to give? Means what? You are going to keep the summarized information, just like movie. If you went to a movie, okay, how you are going to write in your diary? All the 1.5 hour information of that movie? No. You went to that movie is good or bad, or you get bored or not, just write it in 2 lines, like summarized information. Okay? Now, here you are going to implement the referential integrity. Referential integrity means what? Implementing the foreign keys. Okay. Now here you are going to do the historical integrity. Means what? Okay, if you want to do the analysis, entire week's information should be together, month's information to be together, or year's information should be together. Historical integrity should be maintained. And supports day-to-day business, supports for long term. Okay, long term means what? You might do the analysis after 10 years. Yes, you can do. After 20 years, yes, you can do. After 50 years, yes, you can do. Here, you are going to implement the functionality. You are going to implement the functionality to do some transactions. But here, you are not going to do any transaction. Then what is the purpose of? Then what is that requirements? Means what? What analysis you want to do? What information you want? Only. There is a bunch of information. What information you want? Tell me the requirement. I am not going to implement or change any information. Now, obviously, it is going to be the normalized design because we did it. Think out. Here in the normalization, what is the normalization? Removing the repeatancy, reducing the redundancy, increasing the granularity. Okay? Then we are doing oppositely. We are managing the redundancy. We are not worrying about the repeatancy, and we are cutting down all the, we are integrating, no? When we are integrating means what? We are cutting down all small entities. Means what? We are putting, means are we doing reverse process of normalization or not? Are we doing reverse process? That is called denormalization. That is called what? Denormalization. Okay, let's go on the structure of the system. Okay, this operational system, you are going to do the ER diagram, entities and their relationships, and implementing the referential integrity in the system. But every entity is having its own information, and every entity is having separate information here. Now, if you have the entity information means what? That's what, coming to your point. Now, two-dimensional information means what? Rows and columns information will be there in the entity. Okay, rows and column means what? Product and product color is a property on the columns, and the rows, first product color is red, second color product color is black and blue. That is your product entity. Now, let us come to our system. Now, what we need to do? We need to have we cannot just store the product information there. What we need to store? Historical information with respect to the product. Is that true or not? The same product entity, consider if somebody want to do the analysis on the product. Now, what we need to store? Here, we stored product ID, product name, product color, product price. 4 columns are there. Okay, 4 columns are there. Then what we need to store here? Same, product name, product ID, product color. Then what? Then what? Product price. Now comes to the product price. You store the product price today. What happens to the price tomorrow? Same property, the value changes. Then where you are going to put this value? Same property, you have after 1 month, one more value. After 2 months, one more value. After 3 months, one more value. Means what? Same property, same dimension, which is having another one. Means what? You need to create another dimension parallel to that over the time period. Over the time period. Same property, because you cannot put the another property. You cannot write the price after 2 days, price after 3 days, price after, how many you can write? You need to keep on writing. 10 years means what? The table will have the thousands of columns. You cannot write like that. Then sometimes you don't know when the price is going to be changed. Then how can you write it? Then you need to note down at what time the price has changed. Same price, then write the date. Then same price, different price, date. Same price means what? Are you going to manage this in the 2-dimensional format? No. Then you need to have the multi-dimensional. Multi-dimensional means what? One parallel column and one parallel row. Then how many? One parallel, you can watch the 3-dimension, no? What is the 3-dimension means? 3-dimension means what? The image will be reflected in the 2 layers. Okay, then you can see that the image. Okay, on the same one surface, you are seeing in the 2-dimension, the same image will be reflected in the 2 layers. It's 3-dimension. Okay, one more layer extra. One more layer extra, 4 means what? But actually physically can you put a 3rd dimension? It's not possible. Whatever you are viewing is virtual representation with the glasses. 3 dimension is not physically possible. Okay, that's only virtual representation. by looking at we feel that one, that is the third dimension. But system also. But what we are going to do? We are going to repeat the same information. When the product is having the date, then we are writing product number 1, okay, which is having the color red and price $100. Then we are going to have the date on so and so date. Then what you're going to do? We need to repeat this product number 1, red. That repetition might be here or here, okay, after 2 months or after 3 months. Then same price, then the price is going to be $100 or like $110 on so and so date. Means what? Same information we are repeating. Same information are we repeating or not? We need to repeat it. But physically, we cannot put it as in the third dimension. But what exactly we are doing? Same property, different values. That's why we are doing it. It's called a multi-dimensional system. Okay, multi-dimensional system. Now, that's the reason this same product entity here, it is going to called as product dimension. What is that called as? Here you can call it as product table. Here you can call it as product dimension table. Then first component of your data warehouse is what? Dimensions. Sorry. Dimension table. What is a dimension table? What is a normal table? The collection of information with what you call collection of identical information. You call it as an entity. But here, collection of historical transactional information with respect to that entity is called dimension. Okay, here product dimension. Then what you need to do? Then again customer dimension. Then what? Then you need to do the analysis based on the dates or the time period. Then what you need to do? You need to collect all the information on which date you did the transactions. Then collect and everything, keep it together. You can call them as time dimension. Okay. Then because then if you want, you don't need to have the product orders. Do you need to have the order information? Because the product is sold to which customer is already stored along with the product dimension. Again, do you need to have the product order dimension here? That information is already included in the product, no? Product sold to which customer on which date, what price. Everything is included. Then why you need to write again? All the historical, all the relational entities will be disappeared in the data warehouse. Then you will go with the main entities in what you want to do the analysis. That main entities you are going to call them as the dimensions, product dimension. Now, then you will get the extra entities like time dimension and region dimension, any extra dimensions. Means what? Region dimension means what? Location-wise transactions collect together. Time-wise transactions collect together. Product-wise transactions collect together. Customer-wise transactions collect together. Then every dimension will have its own historical information. But does it have relation with any other historical? No. Okay. Then every dimension. But yes, yeah, I got all the dimension table. The first component of it is a dimension table. Then what? Then what? How can you do the analysis, man? How can you do the analysis?
Apply query.
Apply query, then it will tell the only product dimensions. You can simply write a queries. Okay, good. You can write a queries, but how can you get the analytical report? Then I want, okay, can you tell me the total number of products sold to that particular customer residing in New York? Can you tell me who is the customer paid most money on last year, December 23rd? December 23rd is here. New York is here. Customer is here. How can you tell? But what exactly I'm asking? All the analysis will be done on two things called how much and how many. Okay, how much profit, how many. Tell me any other words to do analysis other than these words, how much and how many. How can you do the analysis? Tell me, I'm a good person or bad person?
How much, how many, when, where, everything.
Where means what? There is no where.
Location.
No, location is not how analysis. You consider the location to do some analysis. Okay? Tell me.
Examine.
Examine means what? Then how much score you got? How much score you got? Anything, analysis. Which bank is good? Which movie is good? Are you going to decide the movie where it is playing or how it is good? How much score it got? How much action part you like? How much comedy part you like? How much money it grossed? How many actors you liked acted in this movie? Is it the analysis or not? Tell me any other analysis, general analysis. Tell me Franklin. Calvin is a good person or bad person? How can you rate him? Analysis. How many? Don't take it personally. Okay? Tell me how much and how many. These two are called. How much means what? How many products? How much the customer paid? From which location means what? How many locations? Okay? How much amount from each location? Then all these are called measurements to analyze. Then collect all measurements to analyze in one table. That called group of measures is called fact table. Group of measures together into one table. These are dimension table. Other component is what? Fact table. It contains what? The group of measures. But yes, I got collected all the group of measure. But group of measure with respect to what? I want total number of products purchased by total number of customers from New York area. Means what? The total number, how many is the measurement. But how many with respect to what? Products with respect to customers. Means what? These measures table should have the relation with the product and customers or not. Then relate all dimension tables to the fact table. Okay, then the fact table is containing foreign keys of the dimension table, primary keys of the dimension table as the foreign keys. Then this schema, all dimension table which you have the its own historical information, and the fact table is having the group of measures, and then when all the dimensions table connected to one fact table, then how it is look like? This structure is called star structure or star schema. Structure is called what? Star schema, where all dimension table connected to one or two fact table or multiple fact table. Okay.
So each box in the star schema is a dimension.
Dimension, and connecting to one table called fact table. Okay, fact table means what? It is having the collection of measures or group of measures. What measures you want to do? What type of analysis you want to do? Collect those measures only. Exactly. Okay. Then means what? Fact tables are connected to one. Then when somebody is asking the question, do I need to join 100 tables? Yes, to join with these tables. Okay. Then still the people might ask the question. Again, you are joining the tables, no? Again, you are writing a query. When you have all the information together, then we can develop some kind of a mechanism that can extract the all related or analytical information from this schema. Okay, that mechanism is called business intelligence. Okay, that mechanism is called what? Business intelligence. Then what is that business intelligence? Let us go natural intelligence. Okay, what is natural intelligence? When some pain is happening, what will happen? Your hand will go. Or something is going to fall in your eyes, what will go? Who will tell the hand to go and stop it? Your neural system. Means what? How can the neural system is not there? Because that is mechanized or that is programmed based on the concept called natural intelligence. Okay, natural intelligence. And if you are not doing, something is falling in your eyes, and if you are not closing your eyes, means what? There is some problem. Go to doctor. Go to the programmer. He can fix your natural intelligence logic. Is that true or not? Okay, all these are body material is the hardware. Like your computer. When I am clicking on one button, something is happening on computer. Means what? Some program is running behind that. Then means what? Who is writing the programming? Means the computer doesn't have any natural intelligence. No, somebody is implementing. That is called artificial intelligence. Means what? You are developing every program, every game based on what? Artificial intelligence. That's a lot. Now here, from this schema, this is a system, no? From this schema, all possible analysis we need to possible with. For that purpose, we need to develop a program using the concept called business intelligence. And once your data warehouse is built, okay, then you need to have the tool to develop that program. Okay, artificial intelligence also you need to have programming tools, but you should have the tools, no? Then only you can develop the artificial program. You write a code, you don't have the screen and you don't have where you are going to execute it. That's what you are going to work on. Those tools are called business intelligence tools. Okay, then some of those tools, then we have a lot of business intelligence tools available in the market like SQL Server Analysis Services, okay, and Cognos Business Intelligence or Cognos BI, and Oracle BI, SAP BI, okay, like these are the various business intelligence tools, or like a BIST, Sisense, Actuate, MicroStrategy. These are some various business intelligence tools too. Then, are you going to use the tool directly? No, you should have the schema ready with you. Then only you can use the business intelligence tools. Okay, like that, you should have the data model ready. Then only you can use the relational database management system. Then only here also you should have the schema ready. Then only you can use the business intelligence tools to do that. Okay, then that business intelligence. This is a data warehouse. Data warehouse means what? Collection of all these schemas. Okay, then there's another schema is there, Snowflake schema. Okay, that is a normalized form of star schema. Why again normalization came here? Means what? Sometime what will happen? My system is not giving the entire information. I need to refer to the another system for some information. Okay, because I can store only my historical information. No, then for some other purpose, I can refer to the. Then that purpose I need to, like for example, in my diary, I cannot write my own health condition. Who will have my health conditions? Doctor. Okay, in my diary, I can only write, I reached the doctor. I went to the doctor. Bye. Where is my health report? Doctor can tell me. Then I need to refer my doctor to get my health information. For health information, I need to refer my doctor. Then for some kind of information, I need to refer some other entity or some other dimension to get that information. Okay. Then in that case, then you are referring, you are implementing the referential integrity. Then you can call that normalized. Then you have one more entity, one more dimension connected to the other dimension. Okay, but this main dimension which is connecting to fact table is not connecting to here. Okay, then you are getting the information into the another dimension. Then you are connecting to fact table. Okay, this kind of schema is called Snowflake schema. Means what? Extra flakes are connecting. But okay, for better analysis, always star schema is recommended. But in some unavoidable situation, Snowflake schema will be possible. Okay. The collection of all these star schemas is called data warehouse. Means what? Your data warehouse contains multiple schemas. Why we need multiple schemas? Depending upon different analysis. Okay. One analysis might contain one schema, other analysis might contain other schema. You can create one combined schema together, but it will be, that's your wish. That's why I told you, no? Either you can build a data warehouse or data marts. If you want to increase the complications, build everything together. Okay? Or else separately also you can create a separate schemas also. Okay? Data warehouse is a combination of multiple schemas. Okay? If the schemas are 20 or 30, instead of keeping all schemas together in one data warehouse, you can subsidize that data warehouse, 2 schemas into one set. That is called data mart. Subset of your data warehouse. Okay, for keeping, for storage purpose, or for utilization purpose. Okay, no. But actually data warehouse is also a database. Okay, but which will have the transactional historical in terms of dimension table and fact tables. Dimension table and fact tables. Okay, now let us work how exactly the data resides in the system. Okay, now here in the operational system, the data is separated, granularized. Schema is nothing but structure. Schema is nothing but structure. Means what? Here the star kind of structure, no? All dimension table connected to one fact table. Then what is that? If all connecting to one particular concept is called what? star. Okay, like that. That star structure, or you can call them as star schema. Okay, schema is nothing but structure. And schema in data warehouse is also structure. Schema in database is also structure. Few tables are connecting human resource data. That's why we are creating human resource schema. Okay, schema. Now here the data is integrated. Then here the data will be integrated together. And what kind of transactions you apply on the system? You can insert the data, update the data, delete the data. But data warehouse, what you are going to do? Only you are going to load the data depending on the time period. But transactions, I am telling about the transactions. Here also you can read the data, here also you can read the data. But the transaction we are going to do that here, loading. But structure of this system is different and structure of this system is different. How you are going to load it? Okay, this is a separate DSS database, this decision support database. Okay, purpose is what? Only for storage purpose only. The purpose is what? Not for the transaction, storage and reading purpose. Okay, integrated and scrubbed data. Okay, the data you are not going to have the detailed data. Okay, you are going to remove all the unnecessary information. Scrubbed data, and it is a historical data. Most probably it will be in the read-only mode. Okay, read only for reading purpose. Load it and read it. Then various levels of summarization means what? Year-wise summarization, week-wise summarization, various levels of summarization will be there. Metadata. What is the data? Metadata. Data about data. Means what? In the overview, in the OLTP system, you might use SQL Server, Oracle or anything. Then you need to store the data in terms of that. But when your time of analysis, are you going to use the SQL Server for analysis? You might use another tool, no? You might use another. Then, are you going to go with the over type of data? You cannot go. You need to go with the media, okay, lower layer of the data, it's data about data. Okay, lower layer of data, it's data about data. You should use that metadata. Then it will be easy for the understanding. Or else you might bring the data from Oracle system, you might bring the data from SQL Server system, bring it together to do the analysis. Then what you are going to do? Are you going to follow Oracle structure or SQL Server structure? Don't follow any structure. Follow the basic lower level where Oracle can understand and SQL Server data can be understood at the lower level. That is called what? Metadata. Okay, that is called what? Metadata, data about data. Now, then this is going to be subject oriented, means what type of analysis you want to do. Okay. Now, let us do step by step. What is the first step we need to do? Okay. Let us go. What is the first step we need to do? First step we need to do is what? Building a data warehouse. Okay. We need to analyze. We need to get the information. What information we should do analyze, and then according to that we need to design the system. We need to design the system. Once we design the star schema or data warehouse, how the data will be loaded into that schema? The structure is entirely different, no? The table structure is entirely different. Dimension structure is entirely different. How can you load? Are you going to get as it is data? You cannot. Can you create a data in data warehouse? Can you insert the records? You cannot insert the records. Then what you need to do? Whatever the data is available, you need to dump into data warehouse. But the data is in different format, different structure. How can it be matched with the? Then how you need to load the data and front-end tools. We'll do one by one. First step is what? Analysis. Analysis what? You need to have the target questions. What type of decision you want to take? Okay? What type of decision? I want to close down the system, man. Then analysis will be different. Okay? I need to invest some more, input some more money into the system. Some more, one different type of analysis. No, I bought one more company, I need to integrate with this company. Separate kind of analysis. Or else I want to sell some part of my company to another company. Different kind of analysis. Okay? You need to have that. Then you need to realize what kind of information needed for that kind of analysis. Okay? Then timeliness of data. How much data and what time period data need. Then granularity. Then make the data means from where you need the data, how much, where exactly the actual data is located in short format. You need to create. Then create an enterprise level data dictionary. Means what? Centralized data meanings. Okay. Now do the dimension tables and fact tables. Identify the dimension table and fact tables. That is actually the designing of your thing. Once you analyze your need in design, okay, you gather the information on that one. As a business analyst, you need to gather this information and you need to create a requirement. Means what? You need to create a questions. Then as a database people, you need to find out where exactly the information is available. Then start designing in the next step, designing it. Either design or star schema or snowflake schema. Then what kind of, how exactly it is different from the original data. Then what kind of transformation needed. What kind of transformation it needs and what kind of aggregates it needs. Now came to your point. Aggregates means for summarizer. For summarization, you need to have aggregates, no? Then if some of the aggregates means what kind of pre-calculated values you should have. For example, when you are calculating the total profits, that means what? In the transaction system, there is no column called profit, no? Then what you need to do? You need to calculate the profit by subtracting the sold amount from the original amount. Okay? Then you need to calculate. Then define the hardware and software. What kind of hardware you want to use? What kind of software? Means what? You need to design the star schema or snowflake schema in the design. Okay? Then next, after designing, now your schema is ready. Your OLTP system is there and your schema is ready. Schema is empty right now. Okay? With the dimension tables and fact tables, no data is there. Now what? Then what you need to do? Exactly. Then find out what exactly the fact table and dimension table are. Take the dimension tables and fact tables separately. And what data needs for each fact table and dimension table. You need to design one document called data mapping document. Okay, data mapping document. Here the business analyst role will be critical. Okay, important. Data mapping document means what? How many columns are there in your dimension table? For each column, from where you need to bring the data. Source columns, destination columns. You need to write it in Excel sheet. Okay, where it has a source column name and destination column name. Then that is called a data mapping document. What source data is matching with the destination data? Destination is your dimension table. Source is your normal table, either one table or multiple tables. Okay, that is called data mapping. Data mapping document is nothing but only simple Excel sheet. I'll show you. Okay, simple Excel sheet. Okay, where you will write one side of Excel sheet is what? Source, table name, column name, database name, table name, column data type, and the target table name, column name, data type. Or for this column, you need to add 2 more columns and put it there. Then you need to write the business logic, the last column. Okay, that is called data mapping document. Now once you decide that, then start importing the data. But can you just directly import the data? Then you need to transform the data because the source structure is in the OLTP format, okay, and the destination structure is what? OLAP format. Here you have the ER model, here you have the star schema. Then means what? Is the data is going to match? Exactly? No. Then you need to transform and clean the data. In what? You are not importing. Importing means what? Extraction and loading. Take and load. That is called import. You are not doing anything in the middle. Import and export. But here what you are doing? You need to transform. Then here you need to use the tool called, what is that tool? ETL. Means what? Extract, transform and load. What is that tool called? Extract, transform and load. Okay. Then you need to use the tool called ETL. Then what are the various ETL tools? We have with our SQL Server, one tool is called SQL Server Integration Services. And the other ETL tool called Informatica. And other ETL tool called DataStage, or right now they are calling it as IBM Information Systems. With IBM. Okay? Informatica is third party, DataStage And Oracle guys have Oracle Data Integrator, but that is not popular. Okay, SAP guys have the Business Objects Data Integrator, BODI. That is not also much popular. Mostly used tools are these three: SQL Server Integration Services, Informatica, and Data Stage from the IBM. Okay, these are the three popular ETL tools. There are many: Ab Initio, okay, Business Objects Data Integrator, BODI, and Hyperion Data Integrator. A lot of tools are available, but popular tools are these three. Okay. Now we are going to learn about SQL Server Integration Services. Okay. Now, next, after loading the data, now the data warehouse is having the data. Then what you need to do? You need to know how to read the data or how to implement the reporting tools or BI tools, business intelligence tools. Okay, that is also BI tool and also one of the reporting tools, but you can call them as BI tools. Implement the BI tools to view the analytical information or decision information. Like just now I did it on the Excel sheet. Okay, like that is developed by the SQL Server Analysis Services, like BI tools. Or else you can use the advanced level of analysis. You can use the data mining tools. Okay, SQL Server is also one of the data mining tools. Okay, now or else you can use a GIS system. What is GIS system? Geographical Information System for the deeper area-wise analysis. But we are not going to work with that system. We are going to concentrate much on the BI tools, then data mining tools. Okay, brief about the data mining. And then last, test and deploy on the system. Okay, then we can see actually how exactly happens. Then the operational system might be normal operating system, it might be ERP system, it might be CRM system, it might be normal flat files. One organization will have, for example, one organization for payroll they might use another system, for sales they might use some system, for CRM they might use CRM system, for e-commerce they might use a separate systems, no? Or somebody use the one integrated system for all these things. It depends upon the company. It depends upon the company. Okay, then if they are using for analysis, what you need to do? We need to bring the data from all different systems. Then how can we bring? Then we need to use the ETL tool, then load it in the data warehouse. Load it into the data warehouse. Then we need to use the analysis and reporting and data mining using the BI and reporting tool and the, okay. Then do the testing. Then is the analytical testing. Okay, we need to use the most of the analytical testing will be used with the same BI tools only, or else manual testings will be done. Okay, whether you need to make sure that your analysis is right or not. Okay, or else people will take the decisions. Key thing is the testing, whether your analysis is right or not. Okay, now let us work on the SQL Server part, how exactly these things will happen. Servers, anything is in the real time is on the servers. Whatever you want to use, Windows Server, IBM machines. Servers should be big. Server should be big. Don't worry, in the real-time environment, you might see the server rooms, whole big of these rooms, with the rack servers and all these servers, clustered environments. Okay? Don't worry, there is a TEBS of servers and hundreds of processors included with that. Okay, I'll show you. Go to the Google and search for the server room. It doesn't mean. Don't worry about the space right now in the data warehouse. Okay, worry about what? Analysis. Okay, then if you are worrying about the, do I need to purchase a 2 pages diary or 20 pages diary? Okay, depending upon how much you want to write. Okay? Yes. Purpose is whatever. You can use the cloud computing for warehouse. You can use cloud computing for normal storage also, OLTP storage. Okay? Depending upon how much you want to do the analysis, how much money you want to invest. Okay? Now here, let us go here. Okay. Now you can concentrate on here. Operational sources might be coming from an ETL data warehouse is there. Then you can use the reporting analysis on the mobiles, on the dashboards, and the graphs on the cubes. Okay. Now we are going to work on that one. Everything is possible in using the SQL Server analysis services. Then first we are going to learn about the tool SQL Server integration services. Then we'll learn about the SQL Server analysis services. Okay. Then we'll learn about the SQL Server reporting services for exclusively for analytical purpose. Okay. We already learned for the operational reports. Okay. Then also we are going to learn about the SQL Server reporting services for the analytical reports. Okay. That's we are going to concentrate here. Now, in the bigger level organization, what exactly they will do that? Okay. Then if they might have the data in multiple locations, transaction systems in the all over the world. Then bringing everything together, it is going to be the time-taking process. No? Then what they will do is that they will maintain one new area called staging area. Okay, until the entire data comes into the storing in the staging area, then they will move into the data warehouse. In the data warehouse also, they will define into the different data marts. Split up. That's what I am telling. Okay, data marts. Then they will develop the reports. This is the bigger level organization structure, and in the smaller level organization, okay. Okay, smaller level organization directly moving the data directly to the data warehouse and developing the reports. You cannot call it as a buffer. The staging area is a physical structure. Yes, temporary location, but buffer is a virtual location. Okay. And now, physical staging area, people will maintain the staging area, loading the data to here and loading the data to here. You need to write two different ETLs. Okay. Now here from there, and you need to here you don't need any ETL. Then only you are separating the data into the sales analysis. You can give to one team, purchase analysis and inventory analysis to another team. Data mart. Okay. You are subsidizing, and then end of the day you are developing the reports and data mine. Okay, then when it comes to the SQL Server structure, okay, then we can develop the data warehouse, and the SQL Server can be able to take the data from different systems, and you need to do the operations, and we can develop the data warehouse development, and we can develop the cubes using the analysis services. And BI solutions can be implemented on SharePoint or SQL Server reporting, and or normally on the Excel sheets. Okay, we are going to work on those things. Okay, that is the entire story of your data warehouse. What is the purpose? What is the end results? Okay, is that the end results is going to be your decision support system. Some people can call only data warehouse is a decision support system, but data warehouse is not alone is a decision support system. Okay. Data warehouse is not alone decision support system. What happened? Okay. Now data warehouse is a not alone decision support system. It is only the middle part. When you go into this, okay, here it is a data warehouse. Okay, here it is a data warehouse. People call it as decision support system. Is not alone this system, or not alone this system, or not alone this system. Combination of everything is called decision support system. Building the data warehouse and developing the reports. End result is called decision support system. System means what? Combination of multiple systems. Okay, but you can call it as OLAP system. Okay, then once you develop the cubes using the analysis system, you can call it as MOLAP system, multi-dimensional OLAP system. Okay, MOLAP system. And there are two terminologies called ROLAP and OLAP. Relational OLAP system and hybrid OLAP system. That you have to tell me by the names. Relational means what? There is a multiple schemas together in related with each other called relational OLAP system. Okay? Or hybrid means what? Maximum information in single schema is called hybrid OLAP. Okay, maximum complete information in single thing, that's called hybrid OLAP system. Terminologies, you don't need to really worry. Okay, that is the entire level. Data warehouse, remember guys, make it clear about your data warehouse. Don't confuse with your database and data warehouse. Data warehouse is a separate system and separate structure and separate concept. And okay, and in the future there is something called big data. And don't confuse with the database and data warehouse and big data together. Though all three are different concepts and different systems. Big data is nothing but, that is also a database. Data warehouse is also a database. Database is also a database. Okay, but big data is called, the maximum amount of unstructured data is called big data. That might be data warehouse data, that might be database data. Okay, maximum amount of. People are keep on storing, no? Then when they're storing from last 10 years means what? The first year data might be in one structure, current data will be unstructured. If you want to collaborate all those things together means what? Okay, unstructured format. Okay, not in a proper structured format. That is called big data. That is our latest concept. It is growing rapidly. How to develop that big data? Then they are coming up with the separately designing the big data. Okay, not in form of rows and columns, in form of multi-level columns. Okay, multi-level columns.
Data warehouse is completely separate.
Yes.
It should have
separate system, separate server, separate database.
Is it dependent on any databases?
Exactly. You cannot create. It has to load the data from OLTP system only. You cannot insert the data, new data, whatever you want. Okay. Like if you go to the AdventureWorks, every version of AdventureWorks will have different version of data warehouse. Okay. Like you can see, AdventureWorks 2008 R2 should have the 2008 R2 data warehouse. AdventureWorks will have AdventureWorks. AdventureWorks LT will have the AdventureWorks data warehouse LT version. Okay. Then you can see here you have the structure AdventureWorks normal. You have the diagram structure. But when you go to AdventureWorks data warehouse, when you create a structure database diagram, you will get lot of schemas here. Okay. Now let us take one schema. Or if you add all the tables, like take fact finance, okay, dimension account, dimension no, customer no, employee no, organization and department group, currency, and yeah, let us go with this please. Okay, some more things are there. Now tell me what structure is that? What schema is this? What schema is this? There are snowflakes. One fact table which is having the measures amount, okay, and primary key. Then it is connecting to account table with the account key. Scenario identifying included scenario. Department group key connected to the department table. Organization key connected to the organization table. But this organization table connected to one more dimension, currency. But this currency key will be used here in the organization table only, not here. This is called snowflake scheme. Okay, the fact table is having group of measures. Here there is only one measure. Finance means what? Total amount. One measure. How much amount? Okay. Then the remaining columns are what? Primary keys of the dimension table. Okay, if I am removing this table means what? Okay, now tell me what is this structure? Star schema. Okay, like that. There is multiple schemas in your structure data warehouse. Okay, that is called. What I mean? Diagram to look at that. You need to understand this is a star schema created. See the columns are here. Okay, then there might be column directly coming from the table or something. But here one more question. How can you create the primary key for this dimension table? Can I use the primary key of the database table as a dimension, a primary key of the dimension table? Here the primary key can repeat because, okay, same values for the multiple dates and everything. Then what you need to do? Then we can ask the system to generate auto-generated primary key for it. That is called surrogate. Okay, that is called what? Surrogate key. While creating, we can write the system.create. Like, for example, every system you can go and check in the structure of the table. Okay. Dimension, geography, or dimension organization, columns, organize. See, primary key, but that is auto-generated. Then if you are generating the script, you can understand. Create table script. Because you are not manually entering the values. Okay? See, identity 1, 1. Auto-generating. Okay? Auto-generating. That keys are called what? Surrogate keys. Means what? The system is generating that keys. Not you are manually adding. Because if you might use, see, parent organization key, that might be the key that is using from the original table. But that might repeat. But here, one parent key can be connected to the multiple organization keys. Okay? Like that. Because one parent key means what? Parent key might be repeated 10 times. But that is connected to the 10 different organization keys. Okay.
We have a system that is in instruction of indexing using the
Good question about the indexing. Okay. But you really doesn't need to care about indexing in the OLAP system.
The purpose of project C, why it is generated automatically?
Because the primary key value you cannot manually enter. You need to keep on loading the data. No? Once 20 records are loaded, okay, then you don't know whether you are loading 21st record or 22nd record or 35th. In the primary key, you can manually create the primary key of product ID and everything. You can create it. Here, can you create it? Because when you are loading the data, one time you might load 20 records, other time the records might be 200 records. Then whenever the loading is happening, you can ask the system to auto-generate those values. Okay, like that. Okay. Yes. Why I am telling you you don't need to actually worry about, because you are not directly writing the queries on this dimension table and fact table. You are going to develop some more summarized system called cubes. Okay. Then with the implementing business intelligence, there you need to worry about your performance. Okay. There here the job is to only to load it from the data into the cube. That is not done. Okay. When you go into this one, okay, you are going to generate cubes with the system. You are not going to use this data warehouse to do the analysis, because from the data warehouse you are going to develop the cubes. Okay, you are going to develop the cubes. Okay, using the cubes, you can call them as using the SQL Server or repositories using Cognos, whatever the word terminology. But this is actually the multi-dimensional summarized information. Okay, this is a multi-dimensional structure, but this is a multi-dimensional summarized information where you can pull the reports from it. There you can worry about how can we quickly pull the information and performance. Okay? Because you are not going to write the queries on this system. Yes, system is going to develop it, and on this you need to write queries. Because can you write a queries? SQL queries means what? You can extract the data by representing the column names. Means what? You are representing one dimension, getting the values of other dimension. Okay, that is called two-dimensional. But your data warehouse is it two-dimensional? Your cube is two-dimensional? Multi-dimensional. Can you write a select queries? No. Then you need to write multi-dimensional expressions called MDX queries. What are those? MDX. We are going to learn about those things also. Okay. Then in the next session, we are going to learn about ETL, how to load the data from OLTP. ETL is not only used for OLTP to OLAP, wherever the source structure is not matching with the destination structure. Okay, wherever is the needed of transformation, there we can use the ETL. Okay, but one of the purpose of loading the data is OLTP to OLAP also, because the structure is not matching. Even we can use Oracle to SQL Server, because the structure doesn't match. No? Okay, Oracle structure is different from the SQL Server structure. There also we can use ETL. Lower version to upper version, there also structure doesn't match. Then also we can use the ETL. Okay? Then we are going to learn about that ETL. Now what I want is that I want you guys to go to the database answers. .org. Unavailable? Okay, here you will find some data warehouse models. Okay, search for the data warehouse. Yeah, big data. Yeah, data warehouses are there. The customers and purchasers data warehouse. See what schema it is. Star schema, where date dimension, customer dimension, and I want you to go through this to understand what kind of analysis is happening in this. There, I told you to, in the year diagram, what kind of business is happening, what kind of transaction. Here you need to find out what kind of analysis are possible here. Okay, because geographic dimension, customer dimension, product dimension, and date dimension is there. Fact tables and foreign keys. How many facts are there? Fact name, name fact, description fact, amount fact, count fact, different facts are there. Now, this total number of names, total description, total amounts of description, everything is there. Okay, I want you to go through it, understand, and we can discuss on those. Then we can move into it here. Okay. And in the meanwhile, what we can do, okay, then what kind of star or snowflake schema we can design for the data models. For example, take customers and product table. Okay, consider this is the year model and take the data warehouse of customers and products here. Keep it together. How exactly the structure difference from data model to data warehouse schema. Okay, we'll put both together. Open a new tab. See here, here it is a product dimension is there, product name, product description, product details. That's it. Customer dimension, customer, where is it? Customer name, customer address, and customer details, and geographic name and everything. Then what you need to do? We need to bring all the products that got purchased on so-and-so dates and all the transactional information. We need to load it here. Then the data model is having what? Customer name, customer phone, customer email, other details. But do we need customer phone and emails here? And customer address. For address, what they did, they created the separate, here there is no address here. Okay. But some address, they are creating a separate address table and joining it. But here, entire customer address is here. We don't need to use the relational tables here. Actually, we don't need to use all those relational entities here. That relational information will be, you can store it here. Okay. Then that is a schema. Then the kind of analysis we can find out. Okay. What are the products name bought by the customer with New York area? How many products the customer purchased in December 2012? And what was the number of difference between the number of products bought by same customer during the year 2012 and 2013? We can do all this kind of analysis. I want you to go through these all models. Okay. Understand. If you have any questions, you can ask. Okay. Then we can start working on the ETL too. Okay. Any questions? I'm going to send you this PPT. Just go through one more time. Just try to understand. Okay. And if you want to know the better understanding of data warehouse, the guru of data warehouse, who is that? Who is the guru of data warehouse? Anybody knows? Ralph Kimball. You can go to the Kimball group. There are a lot of material and given here. You can understand the data warehouse concepts. You don't need to by heart anything, just to understand the concept. Okay, methodologies, because we are going to use data warehouse, BI life cycle. Give a lot of blocks are there. You can go through it, read about it. Okay, he's a guru of data warehouse because there are many people are there, but most of the people are following his, because whatever I explained about the concept of the data warehouse is also Kimball's concepts. Okay. Ralph Kimball. Who is the guru of database, relational database? JF code. JF code. That's why we call them as code rules. Okay? Not JK, JF. I don't know the full name, don't ask me. I forgot. Let's see again. If you want for reference purpose, you can go through his books. Okay?